hi guys. Okay, so today we're going to learn about energy changes in reactions. What will be energy changes in reaction, and will be using fuels to provide energy. So we will learn about how the connection between endo and exothermic with the fuels. Okay, so previously you have learned how to calculate the enthalpy H. Okay, the delta H enthalpy or delta I call it. Delta H, the energy changes. Okay. Uh, between energy out and energy in, okay, for endothermic and exothermic. Fuel. Fuel, using fuels to provide energy. So a fuel is a substance that we use as a source of energy. The energy is usually in the form of heat. Okay, for example, we use for cooking, heating, driving cars, making steam to generate electricity. Many fuels must be burned to release their energy, but not all. So look at I don't know what is this. The amount of energy given out when what Okay, hang. So the amount of energy given out when 1 mole of fuels burn completely in oxygen, we call it heat of combustion. Okay, so if I say heat of combustion, or when I said combustion, it means that you need oxygen. Without oxygen, you cannot have this kind of reaction, combustion reaction. So you need to have oxygen. So here we can see endothermic is a bad fuel, means why exothermic is a good fuel. Why I said that? Because exothermic, it releases energy, so it's a good fuel. Means why endothermic, it absorbs the energy. It's not really a good fuel. Okay, but most of the reaction, okay, most of the fuel they undergoes most of the fuel they undergo exothermic, okay, kind of a reaction. All right, so this is what we call heat of combustion. So what means by heat of combustion? The amount of energy given out when 1 mole of fuel burns completely. Okay, burns completely. If there is not burn completely, you cannot call it heat of combustion. It will be an incomplete combustion. And incomplete combustion, it will produce carbon monoxide instead of carbon dioxide, and it very, very dangerous to your, respiratory system. Okay, so let's see. Comparing two kinds of fuels, okay, fuels that we burn and nuclear fuels. Okay, this one is dangerous. Okay, this one, the fuels that we burn, that we use for our cars, we use to cook. Okay, this is the kind of fuels that we use. Nuclear fuels, no, we don't use nuclear fuels. Okay, it's very dangerous and very unstable. Hey, wait, where's my pointer? Okay, so the fuels, the fossil fuels, okay, oil, petroleum, natural gas, coal. How about nuclear fuels? Radioisotopes, okay, radioactive one, the unstable atoms such as uranium-235, okay, and it's very dangerous. So the key idea, fossil fuels burn in the oxygen in air. So without oxygen, it cannot burn. Okay, so how about nuclear fuels? Nuclear fuels are not burned. Instead, the atoms are broken down by bombarding them with neutrons. Okay, this one you should ask Miss Azida, because you will learn this in physics. Okay, bombarding the nuclear fuels with neutrons. Okay, so we not simply go and heat it. Okay, we need to project the neutrons, or we need to bombard the nuclear fuels with the neutrons. Okay, example, natural gas methane, CH4, burns in air giving carbon dioxide and water. Okay, so this is the example of combustion. Complete combustion, because it produces carbon dioxide. If the reaction is incomplete combustion, not complete combustion, it will produce carbon monoxide instead of carbon dioxide, and it also produces byproduct water and energy. So uranium-235 for nuclear fuels, uranium-235 break down to give smaller atoms such as lanthanum and bromine atoms. So this one we use neutron projection or bombardment of neutrons. So the change, chemical energy is released as heat, atomic energy is released as heat. Okay, when it released as heat, both are exothermic reaction. Right? Exothermic reaction means releasing of heat. Meanwhile, Endothermic reaction means absorption of heat. So how we use this reaction? Natural gas is burned in homes for cooking, heating. In gas-fired power station, the heat is used to boil water to make steam, which spin turbines for generating electricity. So in nuclear power, nuclear fuels, in nuclear power station, the heat is used to boil the water, blah blah blah, generating electricity. This is in a bigger context. Okay. So negative points: the combustion of fossil fuels produce carbon dioxide, and it linked with global warming. Means when for nuclear fuels, harmful radiation is very dangerous. This harmful radiation. Why? Because it can mutate your cells. Means that you can be mutation. You mutation means you should ask Miss Nabila as well. This one, harmful radiation. Mutation means your cell is not normal. Okay, maybe for example, if you had this harmful radiation from these nuclear fuels, okay, you absorb the radiation, the harmful radiation from these nuclear fuels. During pregnant, for example, during the pregnancy, maybe your child probability, or 99% of probability, probable they your child, I don't want to say this, okay, means that is very harmful, and yeah, your child will not born as normal. Okay, so it's very dangerous. Okay, so the product are also radioactive. So when I say about radioactive, means it very unstable. It can be easily explode. Okay, so you need to be really careful with nuclear fuels. Okay, so that's all for now, guys. Okay, and thank you for listening.